Hey guys, welcome back from fall break. 2.5 is where we're headed with more probability. So this week we've got 3 lessons and some practice problems. So this will be a good week to kind of ease back into all this probability stuff. Probability in games, probability with stocks, as well as with driving. So it'll be a good week. So if you have questions, as always, you can reach out. Here we go. Probability in games. We see that Victoria's playing a new video game, and the object is find hidden treasure. So with the hidden treasure, there's some gates. So we got gate 1 and gate 2 that she's hoping that they're going to be open when she arrives. The chance that gate 1 is open is 20%. Chance that gate 2 is open is 30%. The game designers programmed the gates so the probability of both of them being open simultaneously is 0.1. So I'm going to do a Venn diagram kind of off to the side here, just so you can see a way to look at it without getting maybe confused is the goal anyways. All right, so if we have this Venn diagram, and I know there's one here, we'll get to that in a second, you'd think, okay, well it's 0.20 or 20%, and it's 0.30, so 30%, and then it's 0.10. All right, which that would be kind of a logical approach to, okay, well, that's how I'm going to set mine up. But we have to remember that with each of these, so 20%, when we take that and we're saying we have 20 and 10 that are both in the same Venn diagram, so we're seeing that the 10% would be shared, that both of them would be open, but we don't have 30% probability that gate 1 is going to be open. We would say 0.20 minus 0.10, so there's going to be a 10% chance that that gate is going to be open by itself, and then there's another, still a 10% chance, so that's our total 20% that it's open. Then we do the same thing here. There's a 30% chance, but because that 10 is shared, we're going to subtract that, so there's a 20% chance that gate 2, so this would be gate 1, this would be gate 2, and because that 10% is shared, you still would see that if you pulled the circle and kind of separated this circle, there's 20 total percent chance that the gate is open, and that this one would still have 30 total percent chance that the gate is open. But that's how we kind of clean up the way that we look at the Venn diagram or the model for this. The other helpful part of this is you can identify the amount of people, or excuse me, the time that the gate is not open. So we know we have 10% and 10% and 20% where the gate will be open. So that's 40% chance that the gate's going to be open. So what that means is outside of this, there's a 60% chance that the gate will not be open. All right, so knowing all that, let's look at our questions here. What's the probability that both gates are open when Victoria reaches this part of the game? So what's the probability that both of the gates are open? We would take the information that we just saw, where we see, okay, the game is programmed so that both gates are opened at 10% of the time. So you could say 0.10 or 10% of the time that the gates are both going to be open. What's the probability that only gate 1 is open? So, well, only gate 1, that's also right at 10%. So 0.10 or 10%. What's the probability that only gate 2 is open? All right, so you see how once we got this Venn diagram, we can kind of find all this stuff pretty straightforward. So getting the setup is the hard part. All right, then we see what's the probability that neither gate is open. Well, we said if 40% is the probability that they are both open, then 60% was the part down here that we said is outside of the time period when there's an open gate. So that means we have 60%. Or you could do 0.60. What's the probability that Victoria finds exactly one gate open? So this means nothing can be shared. So when we look at the Venn diagram again, we see, all right, this is when only gate 1 is open. This is when gate 2 is open. And this is when both gates are potentially opened at the point 1. So it's saying what's the probability that exactly one gate is open. So gate 1, just gate 1 would be a 0.10 or a 10%. Just gate 2 would be a 20%. So the probability that just one of those is open would be 30% chance that just one of the gate is open. All right, Victoria encounters another challenge in the game. If she zaps a target and she's able to capture a bonus shield. All right, so we're trying to get a bonus shield, not necessarily a shield Pokemon pack, but you know, you get the idea. Victoria can hit a target in one try an average of 60% of the time. So we know, okay, there's a number there. It's math, so that's probably important. All right, so 60% of the time. Draw a model of the situation to help answer the next question. All right, so we see that when we're trying to draw this model that she's coming through and she's trying to come right and just zap. All right, can we zap the target right here? If she is able to get it 60% of the time, that means that she hits it and she's very excited because she gets that shield. So 60% of the time. What that means then, what's not said, is that means she misses 40% of the time, which is okay. You know, it's all right. We're all, you know, working at our own pace here with this getting our shields. So we got our 60. Then from there, we're going to branch out again because there's a second target that if you have 0.60 one time and then you do 0.60 again, then what's going to happen there is here, let me change the color here. All right, so we got 0.60, and then if she is able to take another shot times 0.60, then that is 0.36. So that's the number if she's on target 2, and then goes again and hits, we got a 0.36. All right, then for target 2, we do the same general concept, but with the misses. So we are assuming that, okay, we hit, and then we're going for the next target. So if we hit and we're going for the next target, then it'd be 0.60, and if she happens to miss the second one, that was a 0.40, so that's 0.24. So this is a miss, and that's 0.24. So that's building off of the second one. All right, so now let's see what we got here. What's the probability that Victoria hits the first target? All right, well, the probability for the first target we saw right away is, okay, well, you know, the chances 60% of the time. So the first target, so I should have wrote T1 and T2, but target 1 is 60% of the time. What's the probability that Victoria captures the bonus shield? All right, so capturing the bonus shield means that you hit both targets. So we hit target 1, we had 60% chance. Hit target 2, so we are at 36%, or 0.36. What's the probability that Victoria hits the first target, but does not hit the second target, and sadly, does not capture the shield? So she hits the first one, boom, 60, but then misses the second one, and is so sad because it did not capture the shield, but it's at 24%. All right, hopefully that helps, guys. And if you ever have any questions, as always, just let me know.